Hey everyone, welcome back to the channel. Today, we're diving deep into a key concept in probability and statistics, the continuous probability density function, or PDF for short. Whether you're studying statistics, ML, or just curious about the topic, this video will break it down step by step so that it's crystal clear. So, let's get started. Before we talk about the PDF, let's first understand what a continuous random variable is, because that's where the PDF comes in. A continuous random variable can take on infinite number of values within a given range. Suppose, imagine you're measuring the temperature of a cup of coffee. The temperature isn't just limited to 1, 2 or 3 degrees. It can be any number between 0 and 100 degrees like 25.3, 25.34 or even 25.3456. This is no smallest unit. You can keep going infinitely. That's the essence of continuous variables. They can take on any value in a range, not just specific distinct values like 1, 2 or 3. Now that we know what a continuous random variable is, let's talk about the probability density function, or PDF. The PDF is a mathematical function that describes how the probabilities of continuous random variables are distributed across its possible values. And the key thing to remember in this particular figure here is that PDF doesn't give us the probability of a specific value. Rather, it gives us the density at each point. In fact, the probability of a continuous random variable taking a specific value is always 0. So, if you're thinking about the probability of x equals to 2, it's basically 0. But here's the twist. The probability that the random variable falls within a range of values is not 0. In fact, that is what PDF helps us to find. To ensure the probability that a continuous random variable falls within a range, we calculate the area under the curve. Suppose we say that we want to know the probability that the random variable x falls between 2 and 5. To do this, we integrate the PDF from 2 to 5. In simpler terms, we sum up all the small pieces of area between 2 and 5, and that's how we get to the probability. But remember, for any exact point like x equals to 2 or x equals to 3, the probability value is still 0. But here's an important rule. The total area under the curve, or under the PDF curve, for the entire possible range of the random variable must always be equal to 1. Why? Because the total probability of all possible outcomes must be 1. In other words, the probability that the variable takes some values in the entire range is guaranteed. This particular condition ensures that all probabilities add up to 1. It's the way to normalize the PDF and make sure the total probability is meaningful. Now we'll take a practical example. Imagine we have a group of students who took a math exam. The exam scores are normally distributed with a mean of 50 and a standard deviation of 10. So if we wanted to know the probability that the student scores between 40 and 60, we would integrate the PDF from 40 to 60. By calculating the area under this particular curve, we can find the probability that a student scores between 40 and 60. Hence, a continuous random variable can take any values in a given range. A PDF describes the density of probabilities over the range of possible values. The probability of a specific value is 0, but we can find the probability of an interval. And the total area under the PDF curve always equals 1, representing total probability. Okay, now we'll wrap this up with a quick recap. So a continuous random variable has an infinite number of possible values. The PDF explains the likelihood of each value, but we calculate the probability over an interval by finding the area under the curve. And finally, the total area under the curve must always be equals to 1 as it represents the total probability. Okay, That's it for this video. I hope you have a solid understanding of continuous random variables now and the probability density function. So if you found this video helpful, don't forget to like, share and subscribe for more in-depth explanations like this. And if you have any questions or suggestions for future topic, drop them in the comments below. Thanks for watching, and I'll see you in the next video.